All right. Well, good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to be hearing from Daren Starnes about statistics for good. Let your students speak for the data. Before we begin our session, I'd like to tell you a bit more about the Global Math Department. The Global Math Department is an organization that's run entirely by volunteers. To keep the free, high-quality PD, we get great webinar speakers, we have webinar hosts, and we also have writers for our newsletter. Newsletter writers share about an area of math or math teaching that resonates with them, or discusses recent math blogs that help teachers reflect on their practice. If you would like to volunteer or know someone who would be great in any of these areas, please have them email us at globalmathdepartment@gmail.com or have them reach out to us on Twitter. So let's get started with our webinar. But before I introduce our speaker, I'd like to explain how our webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting, and if the chatter gets busy, I'll be sure to catch your questions for the presenter. If you haven't already done so, please introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is if you have one. See lots of people that are familiar to me here. I teach in Bethlehem, Pennsylvania. So our speaker tonight is Daren Starnes, and he will be sharing on the topic, Statistics for Good, Let Your Students Speak for the Data. Daren has taught AP Statistics for 25 years and has been an AP exam reader for over 20 years. He served as lead instructor for the AP Daily Video Project and is currently leads College Board workshops in AP Statistics. Daren is author of 2 popular statistics textbooks for high school students, The Practice of Statistics and Statistics and Probability with Applications. He has given hundreds of presentations about statistics education since 1998. Daren and his wife, Judy, enjoy traveling and especially spending time with their 3 sons and 7 grandkids. Welcome, Daren.
Thank you, Lee, and welcome to everyone tonight. Speaking of grandkids, we're entertaining our oldest sons too tonight, doing a little swimming here, so you may hear one of them pop through in a minute when the swimming stops. I'm coming to you from Charlotte, North Carolina tonight, my hometown. So it's great to be here after the holidays. I hope you all had wonderful Thanksgivings with your families and are looking forward to the next holiday break, not too far away. I'm really excited to speak with you tonight. This is a talk that began just about a year ago. So let me share my screen and we'll get going. The origin of this talk was just about a year ago in Northern California. Some of you know that most of my statistics talks tend to be about statistical content or pedagogy. This one is a little different, and I was quite nervous to give it the first time because I've tried to, for the most part, stay away from topics like this one. I always get nervous that what I think might be statistics for good, other people might not feel the same way about. But I was persuaded to take a shot at this. And so the idea of this particular talk is how we can get our students to think about using statistics for the greater good. And I'm going to let you define what that is. But in the talk tonight, I'll give a couple of examples. I've got my email address there. That is definitely the best way to communicate with me. And for several of the people that I recognize on the webinar, you know that I respond to email. So please keep the conversation going in the chat tonight or afterwards. So let me just do a quick check on who everybody is. So let's see who you are and who we are. If you could identify in the chat if you are an AP statistics teacher, I'd love to know that.
I was gonna say, don't worry, Daren. Little things like that happen.
Yep.
It's just like teaching in real life.
That button, didn't mean to click that button. How about a high school non-AP statistics teacher? I wonder if we have a few of those as well. Could be some of the same people. Okay, how about anybody teach statistics content in a high school math course? All right. So these are just a few of the groups that I was thinking about when I was first preparing this talk. So let me give you the quick plan. We're going to explore two what I hope will be meaningful applications of statistics for the greater good. First, some of you are very familiar with this scenario, the Flint water crisis, but I hope I might give you some new information that you haven't seen before if you have used this example in your own classes with your students. Second, we're going to talk a little bit about treating COVID-19 in the early days of the pandemic, which seems like a long time ago now. I realize that we're still in the midst of the COVID pandemic and that treatments have changed, but this is about some of the early treatments. And then there's a third bonus application that I'm going to mention at the end, one that you might want to look into more that's teacher focused. There's a really interesting study about investigating possible bias in high school counselors' recommendations for AP Calculus. So I'll mention that one at the end and maybe tease that. Also along the way, I'm going to invite you to use some freely available applets to help with the analysis. So we're going to hopefully do some live analysis here, and it's all going to work because technology always works. Just remember that. And we might do a little inferential thinking, informally or formally, depending on what the group is in the mood for tonight. All right, logistics. I put a little pinned message at the top of the chat that gets you directly to this tiny URL so you can open up handout in PDF and Word versions. This particular tiny URL is nice too because it can get you straight to the articles that I'm referring to in the talk and also to the data sets that we're going to be using. So you can see at the top I've got PDF handout, Word handout. There will be an answer key version that I will share at the end of the talk. I just want to make sure the answers are right. So maybe if you catch anything as I'm sharing my supposed answer key, you could let me know if you see anything that's not quite what you were expecting. So we'll have a few data sets that we'll play with along the way, and maybe a few others that you'll want to explore afterwards. So I promised the answer key. I will deliver on that promise. But with that, let's not play PowerPoint anymore. Why don't we get started? So I'm going to take you to my version of the handout. And I mentioned that the first application was going to be the Flint water crisis, which I know some of you have gotten familiar with, maybe used with your students. I'd like to just show a quick video clip that introduces the problem in a really nice way. If you haven't seen this video clip, it's one that I might encourage you to use. So let's start there. And Lee, just let me know if the volume starts to drift here.
The images of the water are shocking enough. Would you...
Don't hit that button.
That's okay. Commercials, that's okay.
Let's skip those ads.
Water are shocking enough. Would you drink that?
And the volume's a little bit low.
My tub, you should see it, is brown. And then come the headlines. An American city failed to provide basic protections to its citizens, and now the children of Flint have much higher than normal levels of lead in their blood. Rick Snyder, governor of Michigan, has apologized.
I'm sorry, and I will fix it.
President Obama declared a national emergency.
You can't shortchange basic services that we provide to our people.
And now 2016 presidential candidates are starting to weigh in.
The governor of that state acted as though he didn't really care.
Lead poisoning is terrible and terrifying. No amount of exposure is safe. And there's evidence that years after we got it out of paint, gas, and more, it contributed to a drastic drop in crime in the 90s. The city has switched back to cleaner water, but the effects will last decades. We take clean water for granted. How could this possibly happen in 2016? Well, you've got to rewind to 2011. Flint was broke. It had lost about half its population after the car factories closed. It had $1.1 billion in unfunded pension costs. It had to cut half its police force. Michigan had a solution called emergency managers.
Now he's been appointed by the governor to turn around Flint's finances. Mike, welcome.
These managers can make cost-cutting measures without the normal political procedure.
I think what we have to do is look at the expense side first. There could be services that we can no longer provide in the city.
And they decided the city could save money on water. Flint would stop buying water from Detroit and join a new regional water system. And as a temporary measure, Flint would use water from the Flint River. The switch happened in 2014.
Here's the Flint.
And who decided to do this exactly is under intense debate. But regardless of blame, the story gets worse. Residents saw and tasted the dirty water and started complaining.
Water's brown, has a bad odor. I'm afraid to even feed it to my cat or my dogs.
We should not have to pay for the water. It's nasty.
But the city claimed federal tests showed the water was safe. An employee at the Environmental Protection Agency leaked a Michigan report to a local activist, which showed the water had higher than normal lead levels. The city's response? Flint told the woman the lead came from her plumbing. It took an outside investigation by Virginia Tech researchers that found elevated lead levels in the water for the state to admit there was a problem in September 2015.
So the corrosion's eating up the pipes, it's eating up the iron pipes, it's causing main breaks, it's causing discolored water, and about 20% of the homes there's just too much lead.
In October 2015, the government bought water filters for its citizens and switched back to water from Detroit. Before all this, 2.1% of the city's children had high blood lead levels. After, it was 4%. For kids under 5 in the most affected zip codes, it was 6.3%. Why did Flint poison its citizenry? Under emergency managers from the state, it wanted to save money. To start to reverse the effects will cost dearly. Just switching back to Detroit's water cost $12 million. A class action lawsuit against the city is pending.
I hope you found that video to be a good, quick summary of the issues that led to the Flint water crisis. It's one that I've enjoyed sharing with student groups. It's short enough that it gives them the basic idea of what happened. So with that, I think I'd like to move into the rest of the story, so to speak. As you saw, this all happened back in April 2014, so it's not that long ago. And it was all about trying to save money for a town that had lost a lot of jobs as the auto plants were no longer needing workers. So as they made that switch from the water source being Lake Huron to the Flint River, one of the issues was that they hadn't thought about the impact of that water change on the pipes in the city of Flint. So there was plenty of evidence that something wasn't right. You saw the water sample there on the video, but they also started to see some things like rash and hair loss and itchy skin, as you see here on the handout. But the authorities kept insisting that everything was safe. Now, the Michigan Department of Environmental Quality does regular testing of water samples from Flint by 6-month intervals. In this case, the next test that was done was January through June of 2015. So what you see here are the data in parts per billion from those tests that were done January through June 2015. They in all took 71 different water samples from 71 dwellings in Flint during that time period. And I'll have more to say about that later. But I've provided the data set for you on the tinyURL document. So why don't we grab that data set? If you just click on the hyperlink in the tinyURL document that was pinned at the top of the chat, you should be able to open the Google Sheet there. And I encourage you to play along because I think it'll make it more likely that you would feel comfortable doing this with students. When I was doing a lot of this with students, it was in the spring term of 2020. A lot of us were learning how to teach remotely on the fly, and any way that I could get the students to stay engaged was something I wanted to learn more about. So we have the data here, lead level parts per billion. What we need to do is somehow select all the data. So there are several ways to do that. You can click and drag, or you can just highlight the column and do an edit copy. Control C for those of us who have certain machines. And once you've copied all the data, then we're going to need to go somewhere to put the data in to analyze. So again, on the tinyURL document, we've got the data set there, and then we're going to go to a website called stapplet.com. That's stapplet.com. Thank you for staying ahead of me there. So we're going to go to stapplet.com to enter the data. Now the data that we have, those are measurements of lead level and parts per billion for each of those 71 water samples. The variable is quantitative, it's numerical. We have a single group of measurements, so we're going to go to the one quantitative variable single group applet. You can see that the way this applet is set up, we've got variable name at the top. So I'm going to put lead level, parts per billion, and I input the raw data, and then I'm going to paste the data here, but you'll see that I carried along the header. In some applets, the header is something that you would want to paste in. In this case, we don't want that to be part of our data, so we're going to need to get rid of the lead level PPB as part of the data list. And you notice even though the data were vertical in that Google Sheet, Stapplet is designed so that it knows to paste it in the appropriate fashion. It doesn't have a malfunction, which is good. And if we just click on Begin Analysis, we should be able to see a graphical display of the data and some summary statistics. And the next few questions will relate to the graph and possibly the summary statistics as well. So the big issue that the Michigan Department of Environmental Quality has to face is once they've gotten the data in there, I'm just going to scroll down on the handout here so you can see the output from Stapplet. Makes really nice handouts, by the way, if you haven't used it for that. The lead and copper action level is what we need to know about. So that level is exceeded if the concentration of lead in more than 10% of the tap water samples collected during the period conducted in accordance with the statute is 0.015 milligrams per liter. Daren's note in bold is that 0.015 milligrams per liter is 15 parts per billion. For those of us who have maybe lost track of our various units from back in the day. And in the statute, it actually says, i.e., if the 90th percentile lead level is greater than 0.015 milligrams per liter. So statistics, of course, is percentile, although we don't all necessarily have the same exact definition of whether it's 90% of values being less than that location or 90% less than or equal to. We're going to follow the statute as it's written here. So I have my first question for you over in the chat. I just want to make sure you're with me to this point. Question 7, based on these data, should action be taken? So again, the action level is if more than 10% of the tap water samples have greater than 15 parts per billion of lead, we're in trouble. And just to help out, 15 sort of right about there where my cursor is. So in the chat, if you would, just should action be taken based on the statute? Just want to make sure you're all with me. Yeah, we got to count those dots, that's for sure. People are counting dots, that's good. So we're getting a couple of people coming up with 8. That's the same count that I got, that's good. I'll keep that as a number on the answer key. So my official answer key when it's published should say something like this. 8 out of 71 of the dots are greater than 15 parts per billion. That is indeed more than 10%. It's a room full of math teachers here in the webinar, so I think we're all good with 8%, but just in case, I went ahead and punched it into the calculator, found out that was 11.3%. So that's definitely greater than 10%. So based just on these 71 water samples, action should be taken. But wait, there's a little more to the story. So city officials omitted water samples from their analysis. One of them had 20 parts per billion of lead that came from a business, and these water samples were supposed to be from households, from dwellings in which people live, not businesses. So they omitted the one with 20 parts per billion. And they also omitted one that had a lead level of 104 parts per billion that was from a home, but they omitted it because the home used a water filter. Now I'll let you ponder that for a second. If the home's using a water filter, that means if anything, it should be filtering out some of the lead if it's working well, this filter. And even with that, the reading was 104 parts per billion. So while on the one hand, maybe the 20 parts per billion, I could argue should be excluded. That doesn't meet the requirements. That 104 is going to become the key to the solution of this problem. But that's what they did. They removed those two values, the one at 20 and the one at 104. So the 20 is here. The 104 is way the heck over there, clearly an outlier by any test that we might use in an intro stats course. So let me ask you now, if you remove the 20 and the 104, should action be taken? Again, if we could get a few responses in the chat, I just want to make sure you're with me on the answer. So we took out the 20, we took out the 104. We're curious to see if more than 10% of the water samples that remain have lead levels greater than 15 parts per billion. So I'll just check the chat over here. Some counting has happened. We're getting some 6 out of 69s. Good. That is what the answer key is going to say as well. Very pleased about that. So they removed those two values. 6 out of 69 is clearly less than 10%. And so no action was taken. Let me play the what if game. What if they had kept the house in that had a 104 part per billion lead level? They didn't, but what if they did and they said, well, we know you used a filter, but your lead level is crazy high. So clearly we need to account for your data. Would that have changed the conclusion? Would action be taken if they put the 104 back in? I know for those of us on the East Coast, it might be a little late to be doing all these fractions, but apologies to everybody on the East Coast. So we put one back in, that gives us 70 values. Should we take action this time? 7 out of 70, 10%. What was that criterion again? Had to be more than 10% that exceed 15. It's right on it, exactly 10%. So the statute still would not have required any action to be taken. So even if they had left that house in the sample, it wouldn't have changed their decision. So you might be thinking at this point, let's let the Michigan Department of Environmental Quality off the hook. It wasn't their fault because they followed their procedures. Yeah, no, don't do that, because their procedure, I'm going to the second page of the handout, their procedure requires that they test 100 households, not 71 or 70 or 69. So they didn't have the sample size that they should have had in the first place. So we're not going to let them off the hook because we don't know what would have happened in those remaining households anyway. So another thing you should know is that 104 part per billion lead level, the one that was way higher than all the others, belonged to Leanne Walters. And Leanne got pretty aggrieved by the fact that no action was being taken. She had young kids at home who were starting to show some symptoms from this change in the water source. And so she reached out to researchers at Virginia Tech. You saw one of them on the video, Mark Walters, and the researchers at Virginia Tech were more than happy to partner with Leanne to have some new data collected from households in Flint, from a random sample of households there. More on that in just a second. While this was all happening, one of the local pediatricians, Mona Hanna-Attisha, was starting to find elevated blood levels in children. So their blood lead levels were going up at a very high rate, doubling since 2014. And also an outbreak of Legionnaire's disease occurred that killed 12 and sickened 87 of the Flint residents. So when the Virginia Tech researchers came in, there was plenty of evidence that stuff was happening. But with Leanne Walters helping them on the ground, knowing the people, many of the people there in Flint, they were able to get a random sample of 252 Flint households to collect data from for water samples. And 42 of those homes had lead levels that exceeded the action level. So I know it's late on the East Coast, but 42 out of 252 is most definitely greater than 10%. And in fact, they were nice enough in their report to provide us with a 95% confidence interval, being 0.12 to 0.21. So in the end, the researchers from Virginia Tech were able to present this more compelling data set. And in the end, the decision was made to switch the water source back to Lake Huron. But a lot of damage was done in the meantime. And this is just one of those very unfortunate situations where maybe some people involved didn't make the right decision. All right, so let me pause there. I'm just curious if over in the chat, I'm curious if any of you have used the Flint water crisis example before in your class, yes or no? Nice to see. Well, my main goal was to hopefully provide something for those of you who haven't used it before to motivate you to consider using it. And for those of you who have used it before, maybe to show you something that you haven't seen before about the scenario. If you're even more interested and want to dig deeper, the Flint water crisis example is heavily detailed on the reference site that I gave at flintwaterstudy.org on the handout. Warning though, it's a place where you can get lost if you really get into it. And I see Christine mentioned over in the chat that Skew the Script, as well as the AP Daily Video series, decided to feature the Flint water crisis as one of our examples. And once again, just like with this talk, I was really concerned that we use things that would be relatable to students, but also not be too politically imbalanced. I think that's always my concern in approaching things that are delicate. This one seems like something that would harm citizens is one we can all come down on the side of good science. And unfortunately, we've had other water crises besides Flint, but this one's certainly recently in our mind. So thanks for sharing the ideas over in the chat. Appreciate hearing what people have been doing. Glad we were able to use Staplet on that one as well. So why don't we jump on to our second scenario, because I want to be able to spend a few minutes introducing that third bonus scenario to try to tease you into. So we've been dealing with COVID-19 for the better part of 2 2/3 years, depending on when you count the start date. And what I want to do is roll back to the early days when people were really desperate to find any kind of helpful treatment. So this second example is about one of the early treatments for COVID-19 proposed over in the UK. My wife is British, so she may have helped me learn about this. So researchers in the UK conducted an experiment to determine whether giving the drug dexamethasone in addition to their usual care, would reduce deaths among patients that were hospitalized already with COVID-19. Remember, in the early days, we really didn't have many ideas on what would be effective treatment. So dexamethasone is relatively inexpensive and has been used to treat some other ailments that led the researchers to believe it might be helpful because of the respiratory nature of COVID-19 problems. So what they did, they took a total of 2,104 patients and randomly assigned them to the dexamethasone plus usual care. And then 4,321 patients randomly assigned to receive the usual care, no dexamethasone. Overall, 482 patients in the dexamethasone group died within 28 days. And how does that compare with the usual care group? There were 1,110 patients in the usual care group who died within 28 days. So their outcome measure at that point was the proportion who died within 28 days. I've given you the source there as well as on the tiny URL document, so you can get free access to that New England Journal of Medicine article from 2021. So the first thing I would want to be sure to ask my students if we were using this in class is, so it looks like only 482 patients died in the dexamethasone group, whereas 1,110 died in the usual care group. So clearly dexamethasone is way better, right, class? Feel free to respond in the chat to that one. Right, 482, that's way less than 1,110. Must be a real winner. Keeping an eye on that chat. Thanks, Tom. Yes, sample size does matter. Always check that the group sizes were, well, not equal. The group sizes were definitely not equal. They gave 4,321 patients the usual care, and about half that number got dexamethasone. So we better not just look at the raw case counts. This is an interesting study in that way because a lot of times students see experiments with equal group sizes. And I think this is a nice case where the group sizes are not equal, almost in a 2-to-1 ratio. So prompting with that, let's do a little more math. Let's calculate the difference, no dexamethasone minus dexamethasone, in the proportion of patients who died within 28 days in the two groups. No dexamethasone minus dexamethasone. Those of you who are really on your game can probably figure out why I subtracted that way and not the other way. I'm a very positive sort of guy, if that's enough of a hint. So let's see. I am getting 482 out of 2104 for the dexamethasone group minus 1,110 over 4321. Or if you go to 3 decimal places, 0.257 minus 0.229, 0.028. That's the difference in the proportion of patients who died within 28 days in the two groups. All right, so a question for you. Let's chat this one out. Do the data provide some evidence that dexamethasone is effective in reducing deaths within 28 days for hospitalized COVID-19 patients like the ones in this study? If the answer is no, then we don't need to spend a lot more time on this example. If the answer is yes, then we might need to dig further. If you're cheating and looking at the handout below where I am, you might know what we're going to do next. Yeah, there's definitely some, it looks like. So dexamethasone, 22.9% of the dexamethasone people Are those fractions reversed? So that's why we're checking this answer key. We will definitely sort that out. I got a positive difference as well. And I'm just looking at the fractions there. It looks like we've got a dexamethasone group going first. Sorry about that. We'll get that cleaned up. So if we focus on the 0.028, it looks like we have some evidence that the proportion of patients in the dexamethasone group who died within 28 days is less than the proportion of subjects who died within 28 days in the no dexamethasone group. So there is some evidence, but the question we would want to ask in a statistics course is there convincing evidence that dexamethasone is effective in reducing deaths for patients like these? Because if the answer is yes to that, then we have a potential treatment for a global pandemic issue. So I asked the question a little bit differently here on the handout, and then we're going to go out to an applet and try this out. And the big question here is it believable or plausible that there's really no effect at all of dexamethasone in reducing the deaths due to COVID-19, and that really the only difference is that some patients who were perhaps more likely to die within 28 days ended up in the no dexamethasone group, and a few more of the patients who were less likely to die within 28 days ended up in the dexamethasone group, and it actually had nothing to do with dexamethasone at all. This is sort of the ultimate null hypothesis, no treatment effect. Maybe all we're seeing here is just differences due to the random assignment, and those individual patients' outcomes may have had nothing to do with dexamethasone at all, or lack of dexamethasone. It might have had to do with their condition and any of their risk factors. So let's do a little analysis on this. We're going to head off to a site that I'm sure some of you have encountered before. I bet Lee is going to get that in the chat before I can do that, so hoping so. The website we're going to go to is rossmanchance.com. And I've added on the applets and the index 2020 just because that's 2021 rather, because that's the new accessible applets. Thank you very much, Lee. So this is where you land. It's got the green banner at the top if you're on the new accessible ones. And the applet we're going to be looking for here is one that has to do with categorical data, because this time we're looking at patients, yes or no, dying within 28 days. So we're categorizing the patient outcomes, and we're doing it for two groups. So I'm going to be looking for something here under statistical inference that has to do with categorical responses and two groups. So I think I would like the two-way tables option here. So I'm going to click on that, invite you to play along. If you haven't used this applet before, it's really snazzy. Technical term, snazzy. As you can see, the website already has some preloaded data and some different data that we can choose from, but we actually want to enter our own data here. So we can enter our own data table. If we click on it, we get a 2x2 table. And my recollection is that that's not too bad, because that's what we have. We have no dexamethasone and dexamethasone. So on the handout, I went ahead and put in what I hope are the corrected values. Dexamethasone is the bigger group. Sorry, no dexamethasone is the bigger group. Dexamethasone is the smaller group. So we'll just need to input those values into the table. So we'll have 1110 and 482 for the quote unquote success, which is unfortunate terminology. Those are the ones that died. So I actually decided to change the labels here just so we don't get ourselves confused about what a success is. And these are survived. So for the survival groups, we've got 3211, and we've got 1622. When you've got all the values entered, just click on Use Table, and that is when you'll know that your data have been accepted by the applet. You'll get a new segmented bar graph that compares the proportions who died and who survived in the two groups. Notice that the vertical axis scale is percentage here. Another thing to notice is that on the left-hand side here, the statistic is set to show the difference in proportions. That's what I'd like. The observed difference was 0.028. subtracting in the order group A minus group B. That's no dexamethasone minus dexamethasone. So 2.8 percentage points higher death rate in the no dexamethasone group. And again, the question is it believable that a difference that large is explainable purely from the random assignment with no treatment effect being involved? All right, now the fun part. On the right-hand side of your screen, if you click on Show Shuffle Options, we get a whole new set of capabilities. And we have various options for how to display these things as a data display, as cards, as a plot. This is a matter of preference, how you like to see these things. I'll show you the cards, but there's a whole lot of cards in this one because we have so many subjects in the experiment. But if you click on Shuffle, you can sort of imagine redoing the random assignment under the assumption that there's no treatment effect. So the same number of people are going to die, 1,592. The same number of people are going to survive for 28 days, 4833. And we're going to see how the random assignment might have come out differently and whether 0.028 is an unlikely value to happen purely by the random assignment or not. So I'll let it shuffle up again because I do enjoy watching the little shuffling people. But again, there's the same number of blue people and each time, 1,592, the same number of green people each time, 4833. So one of the questions I like to ask my students after we've done a few of these is, what do you think this graph is going to look like over here if we keep on doing this a whole bunch? And I'm sort of thinking in 3 areas here. So maybe in the chat, why don't you speculate if you haven't done more than just a few. What do you think the shape and or the center and or the spread of this distribution might be like? Shape and or center and or spread. I'm curious what people are thinking before we do a bunch. And with my students, I'm always curious too. So we've got a couple of ideas coming in over here in the chat. Thank you. We have a few people suspecting something about approximate normality. Gee, wouldn't that be nice? Some centering ideas about maybe centering around 0. I haven't seen too many commitments yet about the standard deviation, which is good because I'm not sure I would commit yet either. We've only done a few simulation trials. And one thing to note, if there's no treatment effect, we'd expect the difference in the proportions who died to be 0-ish. Random assignment might produce a value that's a little above that or a little below that, whatever a little is representing. So once we're done speculating, having students kind of anticipate what's going to happen, we can do a bunch more shuffles. I could do maybe 997 where I'm at 3, so I'd like to get to 1,000. Warning, this is large sample sizes for the applet. So you may need to do a little song and dance while it brings up the simulation dot plot or stick dot plot. I'm kind of liking that the mean is -0, which some of my students wouldn't necessarily recognize as the same as 0. And the standard deviation I've got so far is 0.012. I also know that from doing a lot of these simulation applets, it's a good idea to do as many trials as you can manage. So maybe more than 1,000. Maybe I should do at least 10,000 whenever possible, because then you'll get a better estimate of the center and a better estimate of the variability, the standard deviation. You'll get an even better idea of what the shape looks like, although I think some of you can kind of see it evolving. And there's, again, if you do too many and you have too much going on your screen, it's possible the applet will get angry with you. We'll be patient. But I think I have what I need here to ask my next question if I need to. So yeah, I'll keep waiting. I'm very patient. It's only a timed webinar. What we're going to eventually want to do is figure out whether this 0.028 value is really large or surprising or unexpected if there is no treatment effect. Maybe I shouldn't have done 10,000, huh? I have some confidence that it will actually do 10,000. My confidence will wane in about another minute. I'll think I've crashed the applet. Hopefully some of you have managed to get 10,000 out of your applet.
I definitely got 10,000, Daren. It worked for me pretty quickly.
Hey. All right, we're not going to push our luck. Our mean is still -0. Our standard deviation 0.011 to 3 places, so not that different from what I had before, but the shape looks pretty. There's that approximately normal shape that some of you were anticipating. So I'm sort of curious, if there's really no treatment effect, how likely is it that the random assignment would produce a difference as large as the one in the original experiment of 0.028? So we can just type 0.028 in the box there and have the applet count how many of our total number of simulation trials out of, how many of our total simulation trials as a fraction produce differences greater than or equal to 0.028. For me, it was about 0.0087. Your exact proportions may vary a little bit, but this is a reasonable estimate for the probability value, the p-value. It's pretty small. So the good news in using this analysis, so I've walked you through, just so you know on the handout here, I've walked you through the steps visually. This is the class handout that I used with students as we were investigating this the following year. And we've made it to this final step of looking at what percentage of dots have values greater than 0.028. So if I show you anything on the answer key, it's whatever I got before I prepared the talk tonight. So it's not going to be the same as what I just showed you. The key question is the one down here, based on the estimated probability, which for me was 0.0087. Do the data provide convincing evidence that dexamethasone is effective in reducing deaths within 28 days for hospitalized COVID-19 patients like the ones in this study? Well, yes, there's a very small probability that if there is no treatment effect of dexamethasone, we would get a difference as large or larger than the one observed in this experiment, purely by the random assignment. So I wrote a lengthy treatise here that I would never expect my students to write because they would get tangled up on the various things that we're saying here. But I'm trying to say what I did and talk about how large a difference you would expect purely because of the random assignment if there were no treatment effect. So it's the conclusion of the researchers that dexamethasone is effective in treating patients like the ones in this study. It's also fairly inexpensive. And because there were no other options at the time, this was quite a publication worthy of looking at across the world, at least until other treatments and vaccines were developed to help prevent people from ending up in such dire situations. Now, what really interested me about this study, I don't want to lose my thread here, is there's a little more information if you dig deeper. So we have a statistically significant result, and that was really important in the world. Very important for us to start getting a handle on how to treat COVID patients. But it may not have been the case that all COVID patients were experiencing the same level of help from dexamethasone. So this was a table from the report, and it broke the subjects down by what level of respiratory support they were getting when the random assignment was done. So we had patients in the best case were not on any kind of oxygen support at all. We had others who were receiving oxygen only, but not yet having ventilation. They weren't on ventilators. So you can see now the breakdown within the two groups of subjects. Do you notice anything interesting there? Sorry, I was tabbing over to the site to just see. Yeah, there's something really weird here based on categories, right? Something very different going on by category. And so this was an important post-analysis to do, not just to look at the statistically significant result overall, but to think about how severe the cases were when the patients were randomly assigned. Because if you're not getting any oxygen at all, it may not be helpful / worse than that to be giving people dexamethasone. If you move up to the next level where people are getting oxygen only, it looks like there might be, we would need to check out for statistical significance, but it looks like there might be a small benefit there of using dexamethasone, reducing the death rate a little bit. But we see in the most severe group that are already on ventilation, a pretty large scale reduction in deaths within 28 days. So this was one of those moments where I was really glad I read the rest of the study report, not just the abstract at the beginning. And one of the great things about all of the research that was being done during the pandemic is that most of it was made freely available right off the bat. I'm sensitive to the fact that a lot of people are still in the midst of the consequences of the COVID pandemic. So I also recognize that depending on where your personal experience is and where your community's personal experience is, this may or may not be something that you want to use with students. For me, I think it's important to talk about the serious issue that the world's been dealing with for going on 3 years soon, and to talk about some of the positive things that have come from it, whether it's vaccine development or these early treatment options, obviously more recent treatment options like Paxlovid are things worthy of discussion. At the very bottom of the page there, I also mentioned Bedford Freeman & Worth has agreed to provide some additional materials on their site for those that are interested in doing a little bit more with COVID research, whether it's vaccines or treatments. So I've provided a URL there in case you're interested in looking at more of that. All right, let me pause and just see if there's anything in the chat here, because I'm going to.
There is one question that I put for you in the presenters chat.
Just to try to tease you into it. This is, again, a teacher-facing example. So the third case is about high school counselors' recommendations for AP Calculus. So this is a pretty big issue for a lot of us that have worked in secondary schools. We want to encourage students that are potentially able to master a course like AP Statistics or AP Calculus. We want to encourage them to take those courses. And at a National Counselors Conference, some researchers designed an experiment to try and see if these counselors would be affected by anything other than just the student's performance on a resume. So I'm going to show you one little snippet from the handout, and then I'll come back here live. So on the handout, at the very end, I've provided a sample transcript report. It's not critical that you see all the details, but a sample report that was given to some of the counselors that participated in the experiment. The key is that several counselors were given the same transcript, like this very transcript, but with one exception. You notice up here in the top, the name is missing. So about half of the counselors that saw this particular transcript had the name missing, and about half of the counselors that saw this transcript may have had a specific name on it. Actually, to be a little more accurate, it may be the case that about 1/4 of those who saw a name on the transcript saw a name that would be a typical white, maybe male associated name. About 1/4 would see a name that would be associated as white female. Another 1/4 would see a name that would be associated as black male, and another as the other 1/4 black female. And the remaining group would get that control transcript that had no name. So what I found really compelling about the study, these transcripts were randomly assigned to the participants, was in terms of the way that the counselors rated the students' readiness for AP Calculus. So spoiler alert, to try to get you to take a look at that last example and the study. In each of those cases, like the one that I showed you with that strong academic transcript with a strong behavioral profile, at least one of the groups with names on it underperformed in terms of recommendation relative to the blind transcript with no name. And in that particular one, it was the black female name that was under recommended for AP Calculus and was rated lower in terms of readiness for AP Calculus, even though the transcript was identical in every other way. So I think for those of you who've seen talk about blind auditions and blind review for job applications or mortgage applications, loan applications, this would be the type of thing that you might enjoy looking at yourself. I haven't used it with a student group. I really wanted teachers to be aware of it because many of you know high school counselors who help students make these decisions, and maybe it's a study that you'd want to bring to their attention. All right. Well, I managed to tease in the third one. I hope you'll take a look at it and let me know if you dig further into it and want to talk some more on email.
Yep. Thank you for presenting, Daren.
Again, I wanted to just say this talk started for me well over a year ago, and I was really glad to be able to present it a couple of times. I'm obviously really flattered to be invited to present it here to this group, and I hope it's something that you might consider including with your students. Statistics for the greater good, whatever you think that means for your group of students in your community, without getting overly political on one side or the other, things that you might consider incorporating with your kids. I hope if you use one or both of these examples, you might keep in touch. And if you improve on it, I hope you might share your improvement with me, because we can all do better. Final thought, this will be my last time giving this particular talk. I try to retire talks when I feel like I'm ready to move on to something else. So there may be future talks like this, but I think I've talked out these three scenarios to the point where enough people have seen it now. So I hope I gave you a few things to look at, and thanks to Lee also for hosting.
Yeah, thank you very much, Daren. I think people can hear me. Yeah. So there was one question somebody asked about, just like, do you have students write hypotheses, like with that COVID example? Because they're thinking in terms of drawing a conclusion, or do you think that they get kind of tied up with the whole idea of rejecting the null or failing to reject the null?
Thank you.
So I don't know if you can hear me or not. Can people hear me? All right. I'm trying to wrap us up, and I'm not sure if people can hear me or not. Okay. Frank says he can hear me. All right. Great. Thank you. All right. So, Daren, I don't know if you can hear me or not, but thank you for presenting. Everybody's giving you kudos in the chat. So for those of you
Just
that are
checking, Lee, anything else from your end?
All right. So thank you, everybody, for being here.
Well, have a great night, everyone. Really appreciate you coming, and look forward to hearing from some of you in the future. Thanks, Lee, again.
Yes. For those of you that are interested in more great statistics talks, I would encourage you to check out the North Carolina School of Science and Teaching Contemporary Mathematics Conference on February 24th and February 25th in Durham, North Carolina. The theme is Teaching with Data. The keynote speaker is Beth Chance. The link to more information is in the chat. You can definitely click on that link to see more about that conference. Daren's email address is starnes@gmail.com, I believe. Our next session is going to be on December 13th. The title of the talk is The Art of Asking Questions, How to Train Students to Ask Questions with Joshua Bean. We hope to see many of you for that session. All right. Good night, everyone.